So this is the start of Chapter 2, Coulomb's Law and Electric Field Intensity. And the goals of this chapter is to analyze the forces between static charges and to calculate the electric field associated with any charge distribution. So first the author introduces some terms. One is the permittivity of free space, represented by epsilon 0 or naught. And that's, you should just memorize this one, 8.854 times 10 to the minus 12 farads per meter. And then he goes into this sort of description of Coulomb's law. And so it's a observation, and what it is you have the force between two charges, charge 1 and charge 2, is their product divided by 4 pi epsilon, oops, I forgot the pi, 4 pi epsilon 0, and the distance between them squared. And the charge Q1 and Q2 are in coulombs, represented by a C, a capital C. And like I said, R is the separation between them, and this is this permittivity of free space. And the charge on one electron is 1.602 times 10 to the minus 19th coulombs, just as a reference. So 1 coulomb is equal to about 6 times 10 to the 18th electrons. So 1 coulomb of charge represents a lot of electrons. And then he presents with the vector form, which is what we care about. No one's going to use this form, actually, although it's the experimental observation. We want the vector form. And so F, and again I write vectors with just a little bar on the top, is equal to Q1, that's a charge, and charge on point 1 and charge on point 2, divided by 4 pi epsilon 0. And then we're going to have R, again the distance between point 1 and point 2 squared. And then we're going to have a unit vector which represents the direction between charge 1 and charge 2. So if we had a charge Q1, say at here, and then let's say our origin was here, origin, and then we would have a vector going from the origin to Q1, and that's going to be R1, whoops, R1, and then we had another Q over here, we'll call it Q2, and it's going to have a vector going from the origin, and we'll call that R2. And then we'll have a vector representing the force that Q2 experiences from Q1, and we'll call this R12. That's that vector right there. And this would be the unit vector, A12, in that direction. And this is the force of that charge number 2 experiences from 1. And so R12 is equal to R2 minus R1. And this unit vector, 1, 2, is just going to be R2 minus R1 divided by the magnitude, just like you would for any unit vector. It's that vector divided by its magnitude. And so that gives you the unit vector in that direction. And so let's work a book example. A book example. And in the question, they give you that Q1 is equal to 3 times 10 to the minus 4 coulombs, and Q2 is equal to minus 10 to the minus 4 coulombs. And Q1 is at point M, which is equal to 1, 2, 3. And Q2 is at point N, which is equal to 2, 0, 5. So this would translate into an R1 vector equal to AX plus 2AY plus 3AZ. And this would translate into an R2 vector of 2AX, and there's no Y component, plus 5AZ. And then we have to make our R21 vector, or I mean our R12, sorry. R12 is equal to R2 minus R1. So that's going to be R2 is going to be 2 minus 1 AX plus, and then we take the Y components of R2 as 0 minus 2 AY plus, and then we have 5 minus 3 AZ, which is going to give you AX minus 2 AY plus 2 AZ. So that is the R12 vector. And then we need the magnitude of R12, which is just going to be the square root of 1 squared plus minus 2 squared plus 2 squared. It's just the coefficients of the vector. And so that's going to be equal to the square root of 1 plus 4, which equals the square root of 9, which equals 3. So now we have pretty much everything to solve the problem. And we didn't calculate what our A12 is. So that's our we'll write it one more way. That's our R12 divided by the magnitude of R12. Well, R12 was AX minus 2AY plus 2AZ. And then we'll divide it by the magnitude, which is 3. So now we have everything. So we go, and the question, I guess I forgot to put it up here, is they give you all this information, and then they didn't want what is the force on Q2 caused by Q1. So let's go F2. And remember, our Coulomb's law is equal to Q1, Q2 over 4 pi epsilon 0 R12 squared A12. And so we have Q1 was 3 times 10 to the minus 4. Then Q2 was minus 10 to the minus 4 coulombs, and then we divide that by 4 pi, then our epsilon 0, and then our r squared, which would be 3 squared, because this is equal to r12. That's just the distance. And then we have our unit vector, which was ax minus 2ay plus 2az divided by 3. And so this comes out to be f2 is equal to minus 30 times ax minus 2ay plus 2az divided by 3, which is equal to minus 10 ax and plus 20 ay minus 20 az. So that's the answer right there. And this would be in newtons, because that's a force. And so in electromagnetics, you always have to put your units and put your vector notation. And just as a side note, the force that F1 would experience due to F2 is equal to minus F2. So it's just going to be the negative of that number. So it'd be plus 10ax minus 20ay and plus 20az newtons. So that finishes that book example.